Let's look at filling in this chart using patterns to build exponential functions and talk about initial values, growth or decay, and what the factor and rate are for each. So starting with this given function, 25 is the initial amount. Since 0.05 is less than 1, it's decay. A would have to be bigger than 1 for it to be growth. The factor is what's right in the formula for us, so it's 0.05. We want to write that as a rate. So we want to figure out what that is as a percentage. So we're going to do 1 minus 0.05 is 0.95 times 100. It's a 95% decay if you're only keeping 0.05 as part of the formula. So keeping 5% means the decay rate is 95%. Looking at the last one is the most similar to that one. So I'm going to go ahead and drop down here where the initial amount is 24. And since A is bigger than 1, it's 1.03. This is growth. The factor is whatever's right in the formula for us. And we're going to figure out how much bigger than 1 is this. So we're going to subtract 1 from it. It's 0.03 times 100. This is gaining 3% every time we multiply by 1.03. So every time we multiplied by 0.05, we were losing 95%. But every time we multiply by 1.03, we're getting 3% bigger. So let's continue on this box looking at the second one where we're given C and A. We're going to write the function ourselves. So I'm just going to call it y equals C, which is 300, times A is 1.14 to the x. So 300 is the initial value. Since it's 1.14, that's A is bigger than 1. We have growth. And 1.14, we want to figure out how much bigger than 1 is it getting every time. So we're going to subtract 1 from it. It's 0.14 bigger than 1 times 100. We're gaining 14% every time we multiply by 1.14. Let's look at this box that has the similar things filled out for us. We have C and A. We're going to write the formula ourselves. So y equals 1005, or C times A is 0.15. So we have decay here to the x. I know it's decay because my value for A is less than 1. So we'll put decay here. And how much are we losing from 1? So we're going to do 1 minus 0.15 for decay. We have 0.85 times 100. We have 85% decay. If we're only multiplying by 0.15, we're losing quite a bit. We're losing 85%. Now let's do this one in the middle that has some different data given to us. We don't have the factor to put in the formula, so I'm going to change this percent to a factor by dividing by 100. We get 0.856. So we have 0.856. We want it to be decay, so we're going to do 1 minus 0.856. We don't want to add 1 to it, because then that would be growth if we got a number bigger than 1. So we're going to do 1 minus 0.856 in our calculator. So we're going to keep 0.144 as our A. So we're keeping 14.4%, and that's how we're losing 85.6%. So 0.144 is our factor in the formula, which gives us the function y equals 54 times 0.144 to the x.